Right, so in this module, we're just going to look at a strategy called top-down design in terms of as a way to help us do our problem solving with functions. So we've already actually talked about top-down design in Module 22 a little bit, but now we're going to formalize this strategy a bit. The textbook also talks quite a bit about this strategy in section 6.15. And it's worth a look, worth a read to gain kind of the insight into this design strategy. So top-down design, really, it's actually, you already kind of know how to do it. If you think about writing a long essay or some sort of a long, like a term paper or research paper in another class, you were probably taught to write an outline for that document first, and you would think about, okay, well, what am I going to say in each one of the sections? How am I my conclusions, my introduction, all that stuff. And the first step would have been to start to fill out that outline or that table of contents. When you sit down to write a research paper or a term paper 20 pages long, the reality is you just don't start with word one and just write the whole 20 pages. You start with an outline, you start to break it down, and you fill in the details as you go, right? So you might not necessarily write that entire paper all in order. You might write your outline and then actually write your conclusions first, or write section 3 before section 2. Top-down design just refers to breaking down a problem, ordering the big chunks together, but sort of drilling down for more details and more details as you go. Now, from a programming standpoint, what allows top-down design to happen is functions, and the use of what we would say abstraction. This will let us mimic the way we think about most things. We think about most big tasks as actually just a series of smaller tasks. And that's how we want to start to design our programs. My rule of thumb is never try to solve a program anything complex. Always take the complex task and break it into subtasks, functions. And you continue to do that with the subtasks until the individual functions get so small that it's actually not complex at all. It's actually fairly easy. And so this will ultimately, hopefully, we'll learn, and it'll take a lot of practice, to break down programs into small enough pieces that require almost no thought to them to actually write the code. Now, it'll require a lot of thought to be able to break down the problem, and that's where we want to shift our attention. So I just want to go through one example to do this. So program example 28, from just looking, if we don't think about this 5 functions part, it's actually a pretty straightforward program. I want to ask the user for temperatures, and I actually want to give them the option to say, I want to type in Celsius or Fahrenheit. And then once they tell us what kind of temperature value, what units they want to enter in our temperature with, we'll read the value from the user, we'll convert either to C or to Celsius or from Celsius, and we'll print out both values. Right, so it's a temperature conversion problem. We did this very early on in the semester. But instead of really just putting this entire thing all in one spot, what I want to do is I want to break this down into individual functions, each one of these steps, getting the units from the user, getting the temperature from the user, converting, and then printing the output. I want to implement that as a series of functions. And I'm going to use a combination of function prototypes and function stubs, and I'll define the word stubs in a second, as a way to let me actually write the outline of the program, basically these 5 steps, before I fill in all the details necessarily. And it'll also allow me to start working a little out of order, in whatever order really I please. So let's bring up Visual Studio. And I really, when I say write an outline, I don't mean write an outline in comments. I mean actually start to write an outline in functions. So the user is going to tell us whether they want to enter Celsius or Fahrenheit. So presumably I would have a prompt. I would ask the user to type in a character, C or F. I'd check to see whether the character was uppercase, lowercase. and I'd return, or I'd use that as a variable to do a switch, or to do an if statement to figure out whether I need to convert to Fahrenheit or to Celsius. I'd probably also include input validation to make sure if the user types in, T, I ask them again. I don't want to do all of those details though. All of those details of input validation and dealing with our characters are sort of not the main objective, right? The first step in our program is just ask the user, or get which kind of units the user is going to use. So I'm going to hold that in a character variable. So I'll call it C or F. All right? C for Celsius, F for Fahrenheit. And instead of actually writing the code to do this, I'm going to call a function. And I'm going to say get unit choice. And so I made up a name for my function, but let's think also what it's really doing. It's returning a character, presumably C or F. And I'll make this capitalized. Its name is get unit choice, and it doesn't receive any input because it doesn't need anything to do its job. In fact, the job of get unit choice is going to be to prompt the user, read in a character, do input validation on it, and then return that character. So I can write the function prototype, character get unit choice is going to return C or F, no inputs. Now, I don't want to actually write the details of this. I'm going to instead put a little implementation, but I'm not even going to do any of the input prompts. I'm simply going to return C for now. So get unit choice, instead of really doing the full job, I'm just kind of putting in a placeholder. Right? So every time I call get unit choice, it's just going to return C for now. Right? And that for now part is a real important part. You definitely need to start getting used to programming out of order. Right? Programming sort of in the large. You do the whole outline first, and then you fill in the details later. It's a really good strategy for being able to handle big programs. So step one's done for now. Next step is to get the actual temperature from the user. And again, it's going to be a double. I'll call it input. And I'll just go get it from the user. I'll say input, but I'm not going to write the whole thing here. I'm just going to say get temperature. Get temp from user. And again, get temp from user is going to maybe have an input validation. I mean, I don't know whether I'm going to limit these in terms of the numbers, the upper and lower limits for temperatures or anything. But it could presumably do input validation and present the user with a prompt. But I'm not going to worry about those details. I'm just going to write my function get temp from user. And as you might guess, I'm not going to put the prompt in the definition. I'll just return some dummy variable. 0 is fine. I'll return 0. Now, once I get the unit, I get the temperature, I need to do the conversion. So I need to fill in Celsius and Fahrenheit. Let's create some variables. So Celsius and Fahrenheit. And I'll say, well, if C or F, which represents whether the user was typing in Celsius or Fahrenheit, if it's equal to Celsius, then I'm going to say C equals input, whatever the user typed in, and F equals 2F with C as the input. So I've got a function that's going to be 2 Fahrenheit. Again, same thing. I'm not going to worry about what that equation is at this point. Now, I clearly am accepting a Celsius value into this function. This function is going to return back to me whatever the Fahrenheit value for that Celsius is. So it's got an input parameter. I will write a function definition for it that, you guessed it, returns 0, my function stub. Else, the user must have typed it in Fahrenheit, and I'll just say F equals the input, and C equals 2C with Fahrenheit. 2 Celsius, given a Fahrenheit value, will return back Celsius. And I'll just put return 0 for now as well. So I've got step 1, get the unit choice from the user. Step 2, get the temperature from the user. Step 3, do the proper conversion, so we have Celsius and Fahrenheit. And now step 4, display temps, and I'll pass it Celsius and Fahrenheit. That's a void function. All it's going to do is print out in a nice, a nice formatted way the degrees in Celsius and Fahrenheit. So void display temps double Celsius double Fahrenheit. I don't know if I spelled that right. Yep, I did. Okay. I just chose to call these Celsius and Fahrenheit into the display. I could have called them C and F as well. It doesn't really make any difference. And for now, it's just a void function, so I won't even have it do anything. Okay, so I have this general outline here, and I have the details basically as just placeholders. I haven't dealt with them yet. Build it, run it. You're not going to have anything interesting happen at all quite yet, but now we're going to be able to take our pick in terms of what functions to deal with at what point. So let's run this, and you can see nothing prints out, right? Nothing happens, and the reason nothing happens is because the first thing that my program does is called get unit choice, and get unit choice simply returns C. It doesn't talk to the user like it will. It eventually will. Then I call get temp, and that returns 0. I go through this conversion process, and then I call display temps, and that doesn't do anything. All right, so that's okay. Rather than worry about these details just yet, why don't we just display the temps? So Celsius. Let's make them line up kind of nice. Right, and now we've got our display temps. Now it's still getting called, so just run it. And okay, so we're seeing something, right? Now 0 and 0 come back. And does 0 and 0 make sense? Well, sure it does, because get temp from user, or get unit choice from user returns C. Get temp from user returns 0. Right? We would have fallen into this if statement. In fact, we can prove it to ourselves. We can see that C print out. So we fell into this if statement. We calculated C as input, so that's 0. 2F, well, that just returns 0. And so when we printed out C and F, they were both 0. All right, so again, we can take our pick as to what detail to fill in next. Perhaps maybe since we're already returning Celsius, maybe we should do the conversion to Fahrenheit. So Fahrenheit equals Celsius times 9/5 plus 32. So the to Fahrenheit function is going to change. It's going to be return Celsius times, and now we don't want 9 divided by 5, we want 9.0 divided by 5 to avoid integer division, plus 32. And let's see what happens now. At 0 degrees Celsius, of course we all hopefully know that that ends up being 32 degrees Fahrenheit, and we should see that now, even though the user's not actually typing in the 0. We can test this a little bit, right? So what's 10 degrees Celsius? Well, we can do that by saying get temp from the user returns 10 instead of 0. We see 10 degrees Celsius and 50 degrees Fahrenheit. Not necessarily going to test. We're not necessarily going to trust all that. We can probably type this in, see if it makes sense. Yes, it does. Maybe make sure that we can do decimal. So maybe 10.7. Okay, and that's looking right. Those are the right numbers. Okay, so maybe next, instead of hard coding what the user types in, we could actually do this part. We can do the prompt. So inside getTemp from user, the job of that function is to ask the user, please enter the temperature. We'll read that input in. And there's no input validation on this, so we're really just returning the input. We're always calling it, right? So now we're just going to call it and actually execute it for real. And of course now we're asked what the temperature is. I can put in 10.7 and I get 51.26. I can put in 90 degrees Celsius and get 194 degrees Fahrenheit. So my program's taking shape. I'm filling in the details. After that, so we've got 2C and we've got get unit choice. Well, why don't we do this part first? Because in order to test the 2 Celsius function, it means the user would have to enter in Fahrenheit. So let's attack that problem. Get unit choice is supposed to ask the user to enter C or F. This for Celsius and F for Fahrenheit. Say or, not and. We're going to read that in as a character. And now that character, I want to make sure that the user actually entered in C or F. So I can put an input validation loop over this. And let's say while choice is not equal to C and choice is not equal to uppercase C and choice, let's spell choice correctly, it's not equal to lowercase f, and choice is not equal to uppercase f. So while all of these conditions are true, that means it's something other than these, and I'll keep asking the user. I might, when I return get unit choice, if we look up here, I've actually assumed that we would return capital C. Here, if the user types in lowercase c, I would return it. If I wanted to make sure that that didn't actually happen, and I actually always returned uppercase values from get unit choice, which would be nice because then I can only check against uppercase up here, I can actually call the toUpper function. The toUpper function, it's defined in CC type. Let's add that. And we'll see this a little bit more later on. The toUpper function accepts a character and returns the uppercase variant of that character. And in fact, that could simplify this as well. So we could say choice equals toUpper, choice, convert whatever the user typed in to an uppercase value. Now we don't have to return it differently. And now we don't have to check against quite as many options, which is nice. Makes the code a little bit more clear. So notice I've been sticking in this function a lot. I've been working a lot with this function. It doesn't affect anything else. I've drilled down into the details of get unit choice, and I've made it work exactly the way I want. So now if the user, now of course I'm going to be prompted, right? Please enter Celsius or Fahrenheit. If the user types in lowercase c, it comes back as a temperature, asks for a temperature, and it converts it to Fahrenheit. If I type in E, for instance, I'll just get another prompt. If I type in capitalized F, it continues, and I'm asked to enter the temperature. So if I type in 32 degrees Fahrenheit, I get 0 Celsius and 32 degrees Fahrenheit. It almost looks like things are working. In reality, it's not. If I type in F again and 92 degrees Fahrenheit, still says 0 degrees Celsius. And of course, because the Celsius conversion is really the last detail that we haven't done. So we've filled in get unit choice. We've filled in get temperature, 2F, display temps, but we haven't done anything with 2 Celsius. So again, let's go back to the formula. 5/9 times Fahrenheit minus 32. We'll do a 5.0 times Fahrenheit, and we'll give that a check. Degrees. Whoops. I have to actually type in Fahrenheit. 92 degrees comes back as 33 1/3 degrees Celsius. If we go over here and we type our 92 into our calculator, 33 1/3. So it's working. Now, I went pretty fast through this example, and it's worth sort of going through this a few times, watching me do this a few times. What I want to highlight here is that once I got the general outline, once I thought through step 1, step 2, step 3, step 4, and how they fit together, how get unit choice is going to return a choice, how get temp is going to return a temperature, how I'm going to do my calculations, and how I'm going to display things, I never went back and looked at main again. That's not to say that's always going to work out that way, but that is pretty typical. As I went through and dealt with these individual details, it looks like I spelled Fahrenheit wrong. As I go through each individual function, I really could just focus like a laser right on that particular function and work with it. Some of them are easy, right? Some of them are easy to fill in. Some of them take a little bit more thought and can be crafted a little bit differently. But when we work in what's called this top-down approach, we deal with the top level and we don't get sidetracked by all the little details until it's time to start running the program and start testing it. And in the meantime, we can leave some of the functions that we don't really want to deal with right away simple, as function stubs, just to return some dummy variable. Right? So I've worked highly out of order and in sort of a non-linear way for this example. And I'd encourage you to start kind of pushing yourself into working in that method. All right, so for the lab associated with these last few modules, we've done actually a little bit of the quadratic formula before. I want you to utilize everything that we've looked at in terms of functions to create a program to solve the quadratic formula. As we've discussed before, when b squared minus 4ac, the determinant, is negative, there are no roots. For some coefficients, the value of r1 and r2 are actually the same. That's the coefficients where the determinant actually ends up being 0. If b squared minus 4ac is 0, then it's always negative b over 2 for both of these. So for some coefficients, there'll be 1 root, and for other coefficients, there'll be 2 roots. What I'd like you to do is write a program that asks the user for a, b, and c, and I'd go and write a little function to get a, b, and c. I'd like you to implement a function called quad that will accept the 3 coefficients. It will set, if applicable, the roots of the equation as a pass-by reference input parameter, r1 and r2. But the wrinkle here is that we'll also return back how many roots there are. So quad will return 0 if there's no roots. If there's only 1 root, if the determinant's equal to 0, I'd like you to return 1. In your main function, which I haven't really outlined here, what you'll do is you'll call quad, you'll check the return value to see whether it's 0, 1, or 2, and then you'll print out the right values. If it's just one root, R1 would be the only thing printed. If there's two roots, you'd print R1 and R2. If there's no roots, you should just simply print that there's no roots.